You click a link. The web page loads in under 200 milliseconds. But the server is 8,000 miles away. How is that even possible? The answer is a CDN. Over 60% of all internet traffic today flows through CDNs. Companies like Cloudflare, Akamai, and AWS CloudFront serve trillions of requests every single day. A CDN, or Content Delivery Network, is a system of servers spread across the globe. Instead of every user hitting your origin server, the CDN caches your content at edge locations close to users. Closer server means less latency, faster load times. Without a CDN, every request travels all the way to your origin server, maybe across oceans. With a CDN, the nearest edge server responds instantly from cache. The difference is dramatic. Here's how a CDN request works. A user requests a web page. DNS routes them to the nearest CDN edge server. The edge checks its cache. If the content is there, it responds instantly. That's a cache hit. If it's not cached, the edge fetches it from the origin server, caches it, and then responds. Future users in that region get instant delivery. A CDN is a global mesh of interconnected points of presence. Edge servers talk to each other and to shield servers which sit in front of the origin. This multi-tier architecture means even on a cache miss, the edge doesn't always need to go all the way back to origin. A nearby shield server might already have the content. Here's what happens when content enters the CDN pipeline. First, the origin pushes new content or an edge gets a cache miss. Then headers are inspected, cache control, TTL, and content type determine caching rules. The content is compressed with gzip or Brotli. It's stored at the edge. And finally, it's served to users at lightning speed. CDNs don't just cache images. Modern CDNs can cache almost any type of content. Static assets like images, CSS, JavaScript, video streams, and live content. API responses with short TTLs. Even entire rendered HTML pages at the edge. Some CDNs now run serverless functions at the edge, computing right next to the user. There are two main strategies for getting content into a CDN. Pull-based CDNs fetch content from your origin on the first request, then cache it. This is simpler to set up. Push-based CDNs require you to upload content to the CDN ahead of time. This guarantees the first user never hits a slow origin. Most modern CDNs use pull with smart prefetching. The hardest problem in CDNs? Cache invalidation. When you update content, stale copies exist at hundreds of edge servers. Step 1. You issue a purge request via API. Step 2. The CDN propagates the invalidation to all edge nodes, usually in under 5 seconds globally. Step 3. Next request triggers a fresh pull from origin. Step 4. The new content is cached and served. Modern CDNs also support version URLs and cache tags to make this easier. The CDN ecosystem has layers. At the core, you have origin servers, your actual infrastructure. The inner ring is shield and mid-tier caches that reduce origin load. The outer ring is the edge, hundreds of points of presence worldwide. And orbiting around all of it are the services that CDNs now offer: WAF, DDoS protection, bot management, edge compute, and real-time analytics. The impact is real. Without a CDN, a user in Tokyo hitting a server in Virginia faces 200 milliseconds of latency just from the speed of light through fiber. With a CDN edge server in Tokyo, that drops to under 10 milliseconds. That's a 20x improvement, and it makes or breaks user experience. CDNs are one of the most impactful pieces of infrastructure you can add. They make your site faster, more reliable, and more resilient. If your users are global, a CDN isn't optional, it's essential.